Okay, good morning everyone. So now we are going to discuss about amplifiers. So tuned amplifiers as well as continuation of power amplifiers. So in our last class already we have discussed about what is meant by power amplifier and classification of power amplifiers. Okay, before going to discuss about today's class, once we would like to revise about last class. In our last class we have discussed about what power amplifier and classification. Okay, what is meant by power amplifier? It is an amplifier which is used to increase the power level of the signal. Okay, what is the theme of power amplifier? It is an amplifier which is used to increase the power level of the signal. And while coming to the more one definition, it is an amplifier which is used to convert the DC level to AC level or DC to AC, not AC to DC, DC to AC. And while coming to the power amplifiers, which increases the level of power signal, means which increases the power level of the signal only, of the audio frequency signals, means which increases the level of power level and that lies in the range of audio frequency. What is the range of audio frequency? How much it is? 20 Hz to 20 kHz signals are called audio frequency signals. Okay, so these signals lies in the range of 20 to 20 kHz are called audio frequency signals. Here our power amplifiers are used to increase the strength of these signals. That's why these are also called audio frequency amplifiers. And while coming to the applications where we are using power amplifiers, why we are designing, means these are most probably using public addressing systems. Public addressing systems means what we are using. These are connected in front of loudspeakers, auditoriums, function halls, and also in tape recorders, stereo recorders, MP3 players. Okay, these are the variety of applications of power amplifier. And in our last class, we also discussed about classification of power amplifiers. Power amplifiers are classified according to their period of conduction. So, according to the period of conduction, power amplifiers are classified into 4 types. So, what are the different types we are discussed in our last class are Class A power amplifier, Class B, Class C, Class AB. So, in Class A, the period of conduction is in between 0 to 360 degrees. And while coming to the Class B, the period of conduction is 180 degrees. And in Class C, period of conduction is in between 180 and 360. But in AB, period of conduction is less than 180 degrees. So see here what is meant by period of conduction, why it is lies in between 0 to 360 and 180 and 180 to 360 means, in Class A power amplifier I said period of conduction is lies in between 0 to 360. That means this amplifier amplifies both positive and negative half cycle of the input signal, so that here no power is wasted. And while coming to the Class B, here it amplifies either the positive half cycles or the negative half cycles. And while coming to the Class C, it amplifies greater than positive and less than negative signals. And in Class AB, it amplifies less than half of cycles, less than half cycles, the signals looking like this. So these are the varieties of classifications of power amplifiers. And while coming to the block diagram, it consisting of 3 blocks: input stage, driven stage, output stage. In the input stage, it received the signal is to be amplified, and the driver stage simply acts like a power amplifier which will raise the power level of the signal. After that, it is given to the output stage. Here, the driven stage is used to increase the level of power signal. So, in block diagram, only three blocks are there. One is input, and one is driven stage, and the other one is output stage. So here this driver stage is called power amplifier. It is placed in between the input and output stage. And here simply the output stage acts like a buffer stage, so which connected to the loudspeaker. So finally power amplifiers are used at the last stage of amplification. They are connected in between input and output stage, and they are also called audio power amplifiers. So this is about what power amplifier, and also we are watched the difference between amplifiers, voltage as well as power. So in voltage amplifier the gain is up to 100, but in power amplifier the gain is to only 52, 0 to 50, somewhat less. In voltage amplifier it increases the voltage level, but power amplifier will raise the power level. So these are the differences between the voltage and power amplifiers. But now in today's class we are going to discuss about complementary symmetry push-pull amplifier. So see here the name itself indicate, so it having much more terms: complementary symmetry push-pull amplifier. So see here, while coming to the construction, it consisting of two transistors Q1 and Q2 of different types. One is of NPN type, other is of PNP. So why it is called symmetry means both transistors are made with same material having identical parameters. And why these are called complementary means one is of NPN type and other is of PNP type. And here more one term is also there, push-pull. So why it is called push-pull means here the input voltage is applied across Vin is segregated into positive half cycles and negative half cycles, positive and negative. Here the input voltage is connected to the transistor Q1 through Cin1, and the input voltage is again connected to Q2 through Cin2. Positive half cycles will be given to Q1 and negative half cycles will be given to Q2. So simply what it said means, for the positive half cycles Q1 conduct and for the negative half cycles Q2 conduct. For the negative half cycles Q1 again remains in reverse bias condition. It's unable to produce the output voltage for negative half cycle. So finally Q1 produce the output voltage for only the positive half cycles, and Q2 produce the output voltage for the negative half cycles. So finally what we observe here, no wastage of power is there. Whole power is utilized, both positive half cycles as well as negative half cycles. So this is the construction of what? Complementary symmetry push-pull amplifier. And here 4 resistors are there. Looking they are connected in series, but here middle way they are connected to ground here. Here the resistors are connected to ground. And if we observe cleanly, these resistors R1 and R2 utilized for Q1, R3 and R4 are utilized for Q2. R1, R2 is connected to Q1, R3, R4 is connected to Q2. And why these resistors are used? These R1 and R2 acts as a potential divider biasing. How it acts as potential divider biasing network. So these R1, R2 provide biasing for Q1 and R3, R4 provide biasing for Q2. And these resistors R1 and R2 provide biasing means it makes emitter base junction is operated in forward bias condition, collector base junction operated in reverse bias condition. Finally, the transistor operates in active region. Is it clear? Finally, the transistor operates in active region. Same R3 and R4 also did the same function. It provides emitter base in forward bias condition, collector base in reverse bias condition, and they operates again in active region. And it also makes stabilization. That means it makes operating point is independent of temperature variations and transistor parameters. Independent means the leakage currents, if it is not makes like that, depends on transistor parameters. Cause of transistor parameters, temperature will be increased, leakage currents will be increased. Also, self-destruction of transistors must be occurred, that means thermal runaway. So, to protect the transistors Q1 and Q2 from thermal runaway, resistors R1, R2 and R3, R4 acts like a potential divider biasing network. Okay, and here the output is collected through VCC1 and VCC2. It's clear. And finally, we would like to collect the output from load resistor RL. Okay, and here Q1 provide the output for positive half cycles and Q2 provide the output for negative half cycles. Both would be combined and produced at a load resistor RL. So this is about what? Complementary symmetry push-pull amplifier. So while coming to the construction, it consisting of two transistors of identical parameters, so it is called symmetry. And one is of NPN type, other is of PNP, that's why it is called complementary. And one transistor conducts for positive half cycle, other one conducts for negative half cycles, so that it is called push-pull amplifier. And resistors R1, R2 acts like potential divider biasing network for Q1, and R3, R4 acts like potential divider network for Q2. And the input voltage is applied to Q1 and Q2 through the Cin1 and Cin2. And the output is collected across RL through VCC1 and VCC2. And see here, while coming to the operation, the input voltage must be applied across the base of the Q1 and Q2 through the Cin1 and C2, and the amplified versions. That means Q1 provide the positive half cycles and Q2 provide the negative half cycles is available across the load resistor RL. So in this way, it will utilizes both positive half cycles as well as negative half cycles also. So this is about what? Construction and operation of complementary symmetry push-pull amplifier. So whatever we discussed, that is only there in the slides. Okay, and see, while coming to the slides, once I would like to read it. Consisting of complementary symmetry means one transistor of PNP and the other is NPN. And they have symmetry. Why? Because they are made with same material and same technologies for same maximum ratings. And the resistors R1, R2 provide the voltage divider bias to forward bias emitter base junction Q1, and similarly R3 and R4 provides the voltage divider bias for emitter base junction Q2. And the resistors are so selected that under zero signal condition, the operating point is cut off and so no collector current flows. And see here, and more one slide having that consisting of operation. Okay, while coming to the next one, that is heat sink for the power transistor. The name itself indicates heat. What it contains? Heat sink. Heat sink means it is used to reduce the heat from the devices. It will act like a sink. It will eliminate something. It will do something with help of one device. That device is called what? heat sink. Here the power amplifiers are used to the active devices that have large power dissipation ratings. So these devices are heated more and more, and at a stage the devices will damage due to the production of large amount of heat across the active devices. One way of cooling the device is by increasing the surface area of the transistor. Thus, the heat will escape more easily into the surroundings. This process thus increases the power rating of the device and hence its life also. And another way of cooling devices is by using heat sinks. And see here, while coming to the definition of a heat sink, so it is a device or it is a metallic material which is placed in a closed contact with the transistor, where it is placed in a closed contacts with the transistor to increase the dissipation capacity of the transistor. Why it is used to increase the dissipation capacity of the transistor by reducing the total thermal resistance from the junction to ambient. And the larger size of the heat sink, smaller will be the thermal resistance. It is a metallic heat conducting device. It is placed in the closed contact with a transistor to increase the dissipation capacity of the transistor by reducing the total thermal from the junction to ambient. And larger the size of the heat sink, smaller will be the thermal resistance. And see here, while coming to our next topic, different types of heat sinks. What is our next topic? Different types of heat sinks and their mounting methods. Already I said what is meant by heat sink. How it is molded, it is connected in a closed circuit, it is attached to the surface of transistor. And see here, what are the different mounting methods? Okay, here various type of heat sinks are there. One is push on type heat sink, second one is metal tab heat sink, third one is collector to case heat sink. What is our first one? Push on type heat sink. Second one is metal tab. Third one is collector to case heat sink. So these are the different types of heat sinks. What are the heat sinks? First one is push on type. So second one is metal tab. Third one is collector connected to case. Okay. So see here, some small brief discussion is there here. In push on type heat sink, okay, it is pushed onto the transistor case. Simply the name itself indicates it is of push type. So here heat sink is pushed into the transistor case. Heat radiates more quickly because of increased of its surface area. How the heat will be reduced in the push type heat sinks? Push type heat sinks having large surface area, it is attached to the transistor so that the heat from the transistor is spread into this area will be reduced. And the next one is metal tab heat sink. Here, which has a metal tab in it to work as a heat sink. This metal tab is usually fastened to the chassis of the equipment and hence quickly escape from the transistor of the chassis. And here, next one is collector to case heat sink. Larger power transistor will have the collector connected directly to the case to escape heat easily as possible. So these transistors are to be mounted over the heat sinks of the type that have the cooling fins with flat surface with suitable holes to mount the transistor and the heat sinks. While mounting the transistor as an insulator, it is to be placed in between the transistor casing and the heat sink. As the collector in the metal case itself, in T03 or T066 type of packages requires these kinds of arrangements. So this is about what wide varieties of heat sinks. And what is the use of heat sinks? How it mold? These are of what? Power amplifiers. So next one is what? Tuned amplifiers. So tuned amplifiers are classified into two types basically. First of all, what is meant by tuned amplifier? So these are the amplifiers. Here the amplification capacity must be adjustable. It is tuned to certain frequency range, so that these are called what? Tuned amplifiers. Once see the diagram. So this is the classification of tuned amplifiers. So what it contains? Basically, tuned amplifiers are classified into two types: small signal amplifiers, large signal amplifiers. Okay, and here the small signal are classified into three types: single tuned, double tuned, stagger tuned. Okay, tuned amplifiers are classified into two types: small signal, large signal. Small signal is again classified into three types: single tuned amplifier, double tuned amplifier, stagger tuned amplifier. But basically these are of two types only: small signal as well as large signal. So this is the diagram of single tuned amplifier. See here, it is very near, almost approximately having same construction of single stage RC coupled amplifier, except inductor and capacitor. Is it clear? So in place of load resistor across collector terminal of transistor, here we are using inductor and capacitor. Okay, here the same potential divider network R1 is R2 is used. Input is connected through the input capacitor Cin, and it also having bypass emitter and capacitor resistor, means emitter, bypass resistor and capacitor is there across emitter terminal, and the collector is there, means that is coupling capacitor is also connected across collector. Everything is same except we replace the load resistor across collector with tuned circuit. That means one inductor is connected in parallel with variable capacitor, means the capacitance of the capacitor is varied. If one capacitor is connected in parallel with inductor, so that is called what? Tuned circuit. So this is the construction of what? Single tuned amplifier. Once again I would like to revise what it contains. It consisting of potential divider network R1, R2 are used for providing biasing and stabilization. Biasing means making operating point independent of temperature variations and transistor parameters. If it depends on temperature variations, transistor fall into the shifted from active region to other regions. Operating point also will be shifted. Finally, self-destruction of the transistor is occurred, that is called thermal runaway. To protect the transistor from these variations, here we are using resistor R1 and R2. And coupling capacitor Cin is used to connect the input voltage to the base of the transistor. That means they will block the DC signal and allow only the AC signal. And here coupling capacitor is used to connect the output from the amplifier stage to the next stage, that means load. With the help of this coupling capacitor, only the AC signal will be connected to the or passed to the next stage, and the DC signals will be blocked if there any DC is produced. And here, what is the main theme of tuned circuit that is connected across collector of transistor, which will select only the particular frequencies and it will provide only the amplification for that. And here emitter bypass resistor and capacitor are connected in parallel. These are used for providing low reactance path to the amplified signal. So this is about construction and operation of single tuned amplifier. So see here, once check the slide, whatever I explained that is only there in the slide, but once we would like to read. So it is very important to notice that for an LC circuit, the value of inductance and capacitance should be chosen, that the resonant frequency of the resonance must be equal to the frequency of the signal which is applied. So which factor is important in tuned amplifier? The resonant frequency of the LC circuit is matched with the frequency of the signal is to be applied. And see here, the output of the circuit can be attained by using the inductive and capacitive coupling. Already I told this. The common emitter capacitor is used with the circuit can be bypass capacitor, while the circuits like stabilization and biasing follow these resistors like R1 and R2 and RE. And here the LC circuit is used with the collector region acts like a load. Means two capacitors are used, three with C in is there, C is there and C is there. C in is used to connect the input to the circuit, C is used to taking out the output from the circuit, and CE is acts like a emitter bypass capacitor. And the capacitor is interchangeable in order to contain a changeable resonant frequency. A huge signal amplification can be attained if the input signal frequency is comparable to the resonant frequency of the tuned circuit. See here, by changing the capacitor of the LC circuit, the resonant frequency is made equal to the given input signal frequency. Means by adjusting the value of capacitance of the capacitor, it is maybe going to equal to the incoming signal frequency. At higher impedances can be given to the frequency of the signal through the LC circuit. At higher impedance can be given to the frequency of the signal through the LC circuit. For an input signal with various frequencies, simply the frequency communicates with a resonant frequency so that it will get amplified. Whereas the other types of frequencies will discard the tuned circuits. And see here, this is the frequency response of tuned amplifier. See, observe cleanly, it is approximately equal to RC coupled amplifier frequency. Okay. In your diagram, it here F1 and F2 indicates the upper cutoff frequency and lower cutoff frequency. Here F1 is lower cutoff frequency, F2 is higher cutoff frequency. And this FR is called resonant frequency. Resonant frequency means where the circuit frequency, tuned circuit frequency is equal to the incoming signal frequency. At that frequency is called what? Resonant frequency. At which frequency the maximum gain will be produced. At lower also low gain will be produced. At higher cutoff frequency also lower gain is produced. But at resonant frequency maximum gain will be produced. And see here, at low frequencies the gain must be reduced. At high frequencies also the gain must be reduced. Why? Because here the theme of circuit is only when the circuit frequency is matches with the input frequency, then only it is able to produce the maximum frequency. So already it is there in our diagram. At F1 and F2 the frequency means the gain is 0.7% of its maximum gain. Is it clear? At F1 and F2 it is somewhat better. It achieves the 70% of its maximum gain. But at F4 we will attain 100% gain, maximum gain. And while coming to the word frequency response, if we draw the curve that must be in between the frequency and voltage gain, then the curve is called what? Frequency response. Is it clear? So at resonant frequency only we would like to attain the maximum voltage gain. And see here, this is double tuned amplifier. Single tuned is over, so next one is double tuned. So in double tuned amplifier, in compared to the first one single tuned, what is the main difference is only here the circuit having two tuned circuits. See, these are the tuned circuits. How many number of tuned circuits are there here? Two tunable circuits are there. One is made with L1 and C1, other is made with L2 and C2. So here L1 and C1 is the first one and L2, C2 is the second tunable circuit. Because of these two tunable circuits, 2 times means we are getting maximum frequency at two frequencies. Once it is, if the input signal frequency is matches with the resonant circuit L1, C1, at that frequency also it will produce the maximum gain. And sometimes the frequency of L2, C2 matches with the input frequency. At that factor also maximum frequency will be produced. And while coming to the construction, same way the circuit consisting of two capacitors, one is called Cin, other one is called Ce. Cin is used to connect the output, that means input, to the base of transistor. It is used to avoid the unwanted signals, DC signals, and it will allow only the AC signals. And emitter bypass capacitor Ce provides low reactance path to the signal by taking the help of emitter bypass resistor Re. And whatever the signal is to be amplified is applied to the base of the transistor through the capacitor, input capacitor only. And more one circuit is there that is common for all circuits, that is R1 and R2. It provides biasing and stabilization network for the transistor. So already I said that biasing means make operating point independent of temperature variations and transistor parameters. So how it makes independent means by providing emitter base junction is in forward bias condition and collector base junction is in reverse bias condition. emitter base in forward bias condition and collector base is in reverse bias condition. So the transistor operates in active region. So now the Q point is fixed at active region and the transistor will be protected from the self-destruction. Means cause of effect depends upon the temperature variations. Operating point will be shifted from one point to other point. Leakage currents going to increase. If the leakage currents are going to increase, automatically self-destruction will be occurred. Okay, while coming to the construction and operation, already I explained that is only there in the slide. So once I would like to read the slide. So see here it consisting of the circuits L1C1 as well as L2C2 within the collector segment of the amplifier. What I explained that is only there in the slide. One see here. The primary tuning circuits L1C1 can be tuned towards the input signal frequency. In this stage, the tuned circuit gives high reactance toward the signal frequency. As a result, the huge output becomes visible at the output of the primary tuned circuit. Then it is coupled with the secondary tuned circuits like L2C2 using mutual induction. And these circuits are widely used to connect different circuits of TV and radio receivers. So what is the difference between single tuned and double tuned? In single tuned, only one tuned circuit is there, that is paired with L and C. And in double tuned circuits, two resonant circuits are there. One is made with L1C1, other is made with L2C2. Okay, and while coming to the applications, these are used in TV and radio receivers. And next one is Class C power amplifier. So first of all, what is meant by Class C means? So in Class C, it will provide the conduction for less than 180 degrees. For the looking, the signal is like this, like this, like this, or it may be like this, less than 180. Either the half of the positive half cycles or half of the negative half cycles, or it may be mixing of positive half and negative half. So Class C power amplifiers are the amplifiers amplify the signals at the period of conduction is less than 180. Typically it is in between 80 to 120. So less than 180 means how much it is in between 80 to 120. The reduced conduction angle improves the efficiency to a great extent but causes a lot of distortion. Here the maximum efficiency of Class C amplifier is around 90%. How much it is? 90%. So see here, this is the construction of Class C power amplifier. Here the main differences are no coupling capacitor is used, that means input capacitor, and no emitter bypass capacitor is connected across emitter, and no stabilization network is there, it is made with R1 and R2. Only one resistor is used for provide biasing, that is the resistor RB, and here the input signal is directly connected to the transistor for the sake of amplification. Is it clear? No potential divider network R1 R2 is there, that is replaced with only the resistor RB, and no input capacitor is there. The input is directly connected to the base of the transistor. and no emitter, bypass resistor and capacitor is there. Only one resistor is there that provides biasing. So that's why this resistor is called biasing resistor. It also will do the same function that must be enhanced by the resistors R1 and R2. No output coupling capacitor is there, having only the inductor L1 and capacitor C1. So while coming to the operation, when the input signal is applied, when the input signal frequency matches with the frequency of this resonant circuit, at that moment it will increase the strength of signal and produce the output voltage. And it will reject all other frequencies. It will provide the output voltage for the frequency of the resonant circuit matches to the frequency of input signal. For that only it will produce the amplified versions. This is about what? Class C power amplifier circuits. So whatever I explained, that is there in slide 1. See here. Biasing resistor RB pulls the base of Q1 further downwards, and the Q point will be set somewhere below the cutoff point in the DC load line. As a result, the transistor will start the conduction only after the input signal amplitude has risen above the base emitter voltage, plus the downward bias voltage caused by the RB. Biasing resistor RB pulls the base of Q1 further downwards, and the Q point will be set somewhere below the cutoff point in the DC load line. As a result, the transistor will start conduction only after the input signal amplitude has risen above base emitter voltage plus downward bias voltage. That is the reason why the major portion of input signal is absent in the output signal. And here the capacitor C1 and inductor L1 forms the tank circuit, which aids in the extraction of the required signal from the pulsed output of the transistor. The job of active element here is to produce a series of current pulses according to the input and make it flow through the resonant circuit. The values of L1 and C1 are so selected that the resonant circuit oscillates in the frequency of the input signal. Since the resonant circuit oscillates in one frequency, all other frequencies are attenuated and the required frequency can be squeezed out using the suitable tuned load. Already I told this. So what happened here in this circuit? Resonant circuit oscillates at one frequency now. So at that frequency only, that frequency signals will be amplified and all other frequencies are attenuated. And the required frequency only can be squeezed. That means it only can be amplified by suitable tuned circuit. Okay? And whatever the harmonics or noise present in the output signal, that can be eliminated by using additional filters. They are made with either capacitive, resistive or C-type tank circuit like that. And a coupling transformer is used for transferring power from the device to the load. And due to the heavy distortions in the Class C configurations are not used in audio applications. Of course, these are designed, but these are not used in audio applications because of high distortions are there. The most common application of Class C amplifier is RF circuits like RF oscillator and RF pump. These are not used in audio applications, but these are used in RF oscillators and RF amplifiers, where there are additional tuned circuits for retrieving the original input signal from the pulsed output of the Class C amplifier, and so the distortion caused by the amplifiers has little effect on the final output. Input and output waveforms of Class C amplifier is shown in the figure below. See, these are the input and output. Here we are applying the positive and negative half, where the input signal matches with the resonant frequency. Here it is matched. At that moment only it will produce the output. For the negative half cycle, it is unable to produce the output. Why? Because for the negative half cycle, here the transistor is falling to the reverse bias. Only for the positive half cycles, it will provide the output voltage. And see here, while coming to the applications, the tuned amplifiers are used in ultra high frequency radio relay systems. UHF indicates ultra high frequency. And these are also used in IF amplifiers, means intermediate frequency amplifiers, in super heterodyne receivers. And it is used as RF amplifiers in receivers, and also used as wideband tuned amplifiers for video amplification. And it is used as a very narrow band I amplifiers in spectrum analyzers. Finally, these are used in relay systems, heterodyne receivers, video amplifiers, and spectrum analyzers. So these are the variety of applications also used in satellite transponders, Y amplificators in oscillators. So now I would like to conclude the class. In tomorrow's class, we are going to discuss next topic.